Classification of elements based on electrical conductivity and energy bands. Elements can be generally classified into three types based on their conductivity of electricity. First one, conductors. Second one, non-conductors or insulators. And third one, semiconductors. Examples of conductors are metals such as copper, aluminum, etc. Examples of non-conductors are dry wood, paper, etc. Semiconductors are different concept which will be discussed later. An atom has a nucleus that carries a positive charge and electrons revolving around it carrying negative charges. It has different orbits or shells depending on the atomic number and size of the atom. An orbit is the circular path in which an electron moves around the nucleus. Shell is a group of orbits having the same energy level around the nucleus. The energy level of electrons increases as move outward from the nucleus. Means outermost shell electrons have the highest energy level. Electrons in the inner orbits are tightly bound to the nucleus. As the orbit or shell number increases, the bonding between the electrons and the nucleus reduces. Since the outermost shell electrons take part in chemical bonding, they are also called valence electrons. The circulating path of valence electrons is called the valence orbit. The region influenced by the energy level of valence electrons is known as valence band. In some elements, when an external excitation such as heat, light or voltage, here it is voltage, is applied, the electrons in the outermost orbit can detach from the orbit by acquiring energy from the excitation and will move freely, although they are still under the influence of the nucleus. This energy level is termed as conduction band. In such materials, the valence band and the conduction band overlap partially. Hence, without breaking the atomic structure of the element, electrons can move freely through the valence or conduction band region. This allows the flow of electric current. Such materials are conductors of electricity. Metals are generally conductors of electricity. In the case of insulators, a very large energy gap or band gap exists between the valence band and the conduction band. Because of this large gap, a very high amount of electrical energy is required to excite an electron from the valence band to the conduction band. If a source attempts to excite these electrons, it may permanently escape from the influence of the nucleus. This can disrupt the atomic structure of the material and lead to the electrical breakdown, means which may result in permanent damage or destruction of the material. In some cases, the material may transform into another form and the residue may become carbon. In electrical engineering, this transition of the material is known as the breakdown of the material or dielectric breakdown. Ultimately, these materials do not conduct electricity under normal conditions. These materials are called electrical insulators.